Another episode in making my hexapod, the large hexapod. This is for a magnetic encoder housing. I found that the potentiometers in the linear actuators isn't accurate enough to give me the resolution that I need in order to make the steps as less jerky, I guess is the right word. So I'm going to a magnetic encoders instead and figured out how in the world to mount them. So I'm going to show you how that's all put together. Alright, here is one of the housings that's been machined. This one is, you see right here is the pocket for the encoder itself. Mounting holes are here on the side. On the other side is where the shaft will come through, and as you can see right here is a spot that was machined out so that it will fit on the leg properly, and this right here is a spot for the shaft to rotate the shaft. All right, and here's the disc. It's got a rod. This is a threaded rod, 440 thread on it, that rotates, and as you see that rotates the shaft. Here's how it fits on the leg, and you see the leg has already been pre-drilled and tapped. This is one of the things I was trying to do, is come up with something that would make it relatively simple without major modifications. Take this piece, I'm just going to take one that doesn't have the rod in there. This fits right over top of this like that, and it locks more or less in place with the two screws, then will hold it in place. The wire is then routed on up, and then we'll go into the patch panel. There will also be, I need to machine a cover that goes over top of this portion that will protect that and keep it out of the elements. Got a couple of holes here for mounting a lid. The experimenter board is what I'm using right now to test this thing out. Primarily what I'm doing is coming up with this thing so it's kind of in a mid rotation. Since this is a 360 degrees, there's no start and stop on it. So I wanted to make sure that the encoder value was not going over the zero set point, say like from 4,000 to 4,096, and then it goes to 0, and then it starts increasing again. I didn't want to go over that just because it's going to make it a lot harder to program. Instead, I wanted to validate that the spot that I had the shaft in was about 2,048, which would be halfway, and now I can safely move it both directions. See how good the resolution works. The previous video I did showed that the leg was pretty jerky in its movements, and that just wasn't going to be acceptable for this thing to move well. So this thing's been rewritten, the code has been rewritten with the magnetic encoders for at least the coxa, and it worked out very, very nicely. Went from about a 3 to 4 degree resolution, that's about the closest I could get to move every 3 to 4 degrees, down to almost a half a degree resolution. I think I can even get it better than that if I play with it. This was done by rewriting a PID, the proportional integral derivative control, and came up with a whole new version of it, and it actually was simpler than the old one, and so it runs a lot faster. Next thing will be is finish putting it together and then testing. See you then.